Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem: solve d square minus 2d plus 1 into y equals to x square e power x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2. And highest power of the highest derivative is our degree. Degree is 1. Or just write the given differential equation as d square y minus 2 dy plus y equals to x square into e power 3x. We know that d is a differential operator. Then d square will be d square by dx square. So we can write d square y as d square y by dx square minus 2 into write dy as dy by dx plus y equals to RHS, right? Here d square y by dx square is the highest derivative, so our order will be 2, and highest power of the highest derivatives are degree. Degree is 1. Now coming to the problem. Given differential equation, d square minus 2d plus 1 into y equals to x square e power 3x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 2d plus 1 and q equals to x square into e power 3x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is complementary function and yp is a particular integral. We'll find yc using the rules of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply put RHS equals to 0, then we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q, right? So here we have 1 by f of d into q is of some v into e power ax form, or just 1 by f of d into e power ax into v form, right? Fine. Firstly, let's find yc using the roots of the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 2d plus 1, right? Let's replace differential operator by m, so that we'll get f of m equals to m square minus 2m plus 1. Now our auxiliary equation becomes m square minus 2m plus 1 equals to 0. Right, this is of a square minus 2ab plus b square form, right? The expansion of a minus b whole square. So we'll show you in detail. Just write 2m as 2 into m into 1, and this 1 as 1 square. Now this is of a square minus 2ab plus b square, right? Which is of expansion of a minus b whole square form, right? Now we can write m minus 1 whole square as m minus 1 into m minus 1 equals to 0. Now equate each factor to 0. If you equate m minus 1 to 0, we'll get m equals to 1, right? But here you're having 2m minus 1. So m minus 1 is repeating twice. So we'll get m equals to 1, 1, which are equal roots. Therefore, m equals to 1, 1 are the roots of our auxiliary equation, say f of m equals to 0, which are equal. when two roots say m1, m2 are equal, right? Then m1 equals to m2. Then we can write yc as, since we are having two equal roots, so we'll get two terms under brackets into e power that equal root into x. Now our complementary function looks like yc equals to c1 plus c2x into e power equal root into x. Then yc equals to c1 plus c2x into e power x. Therefore, our required complementary function is, right? Now let's find yp, particular integral. We'll find particular integral using 1 by f of d into q. We have f of d 1 by d square minus 2d plus 1 into q is x square into e power 3x. So this is of 1 by f of d into b into e power ax form, right? Now just compare 1 by f of d with this term with 1 by f of d into v into e power ax. Then for a equals to 3, we'll find d plus a, which is d plus 3 for a equals to 3, right? Now, we'll shift this e power 3x towards left by replacing d with this d plus 3, okay? Simply, we'll replace e power ax towards left by replacing d with d plus a into v. Later, we can operate v with 1 by f of d plus a. Okay, fine. Now, just shift e power 3x towards left into 1 by, replace this d with d plus 3. We'll get d plus 3 whole square minus 2 into d plus 3 plus 1 into the remaining thing x square is equals to e power 3x into 1 by d square plus 3 square is 9 plus 3 to the 6d minus 2d minus into plus minus 2 3 is 6 plus 1 into x square. Now our yp becomes yp equals to e power 3x into 1 by d square plus 6d minus 2d is plus 4d, right? Plus 9 plus 1 is plus 10 minus 6 into x square, which is equals to e power 3x into 1 by d square plus 4d plus 10 minus 6 is plus 4 into x square. Now, if you notice, the term under bracket is of 1 by some function of d into x power k form, right? So here we can apply 1 by f of d into x power k form, right? The procedure of 1 by f of d into x power k. Now we are going to operate x square with 1 by some function of d. Okay, so is equals to e power 3x into, now here 4 is the lowest degree term, right? So let's take 4 common from all these 3 terms, or just write the denominator in ascending form or in ascending order, I can say. Now take the lowest degree term common from all the terms, since the last 2 terms have, okay, No 4. I'm sorry. Here we are having the denominator is of d square plus 4d plus 4, which is in expansion of d plus 2 whole square form, right? So instead of taking 4 common from all these three terms, just write it as some d plus 2 whole square. Okay, it will be easy, right? Not easy. Actually, we can just write the denominator in d plus 2 whole square form. Now, what we are going to do is just take 2 common from these two terms. Then we'll get 2 into. For the first term, you don't have any 2. So let's multiply and divide 2 to this. Okay. Now it will be easy to take 2 common from these two terms. Then we'll get 2 times d plus 2 plus 1 whole square into x square. Now yp becomes e power 3x into 1 by 2 square into d by 2 plus 1 whole square into x square. We know that 2 square is 4, and we can write d by 2 plus 1 as some 1 plus d by 2 whole square into x square. Now split this fraction into two fractions. 1 by 4 into 1 by 1 plus d by 2 whole square into x square. Okay. If you notice, in the second fraction we are having 1 by 1 plus d by 2 whole square, which is of 1 by 1 plus x whole square form, right? We can write it as 1 plus x whole power minus 2, right? Then this becomes e power 3x by 4 into 1 plus d by 2 whole power minus 2 into x square. Now we have e power 3x by 4 into 1 plus x power minus 2 into x square. Now let's use binomial expansion, binomial series expansion. Since 1 plus x power minus 2 is equals to 1, here you are having plus and here you are having minus, right? So put minus into 2x. Next, alternate sign, 3x square plus 4x cube minus plus and so on. Okay. So before going to expansion, let's find derivatives of x square firstly. Derivative of x square is 2x. D square of x square is 2. D cube of x square is 0. Right? See? D square of x square can be written as derivative of x square. We know the value of derivative of x square, which is 2x. Now find derivative of x here. We'll get 2 into 1, which is 2. Right? Likewise, find d cube of x square. Since we are having the value of d square of x square, so we can write d cube of x square as derivative of d square of x square. Now put the value of d square of x square, which is 2, and find the derivative of a constant, which is 0. Right? So from here you'll get all the derivatives 0. So we can neglect higher derivatives from 3, 4, 5 and so on. Okay? In general, d power k of q equals to 0 for k equals to 3, 4, 5 and so on. Right? Fine. Now keeping d and d square values in mind, not values, we'll just have values for d and d square, right? Keeping in this keeping this in mind, we'll neglect the higher derivatives or higher terms involving higher derivatives, we can say. Okay. Now let's expand 1 plus d by 2 whole power minus 2, which is equals to 1 minus 2 into x. For x equals to d by 2, you'll get 2 into d by 2 plus 3 into x square. D by 2 whole square. See, here you're having cube, right? So if you replace x by d by 2, you'll get d cube in this term. And hereafter, you'll definitely get the higher derivatives. So we can neglect terms from here, since you are getting d cube, d power 4 and so on from here. Okay. And this becomes 1 minus 2 gets cancelled, you get d plus 3 into d square by 2 square is 4, which is equals to 1 minus d plus 3 by 4 into d square. Right? Fine. Now, yp becomes now we are going to use the expansion, right? Binomial series expansion. This equals to e power 3x by 4 into 1 minus 2 into x plus 3 into x square minus 4 into x cube plus so on into x square. Which is equals to e power 3x by 4 into 1 minus d plus 3 into d square by 4 minus 4 into d cube by 2 cube is 8 plus so on into x square. Since d power k of q is 0, see here q is nothing but x square, okay? I mean x square is q or q is x square. For k equals to 3, 4, 5 and so on, right? Q is equals to x square, which is nothing but. Now, so neglect higher derivatives from d cube, d power 4, d power 5 and so on. Okay, so we can neglect d cube here. Okay, and all the terms from here. Okay, we are going to neglect all the terms from here. Then our yp becomes already we have the name q, already we have used the q, right, for RHS. So let's name this x square as some capital R for our convenience, so that we don't need to get confused, right? Fine. Now this becomes e power 3x by 4 into 1 minus d plus 3 by 4 d square into x square. The reason why we have chosen the three terms is d cube of x square is 0 and d power 4 of x square is 0 and so on, right? So this equals to e power 3x by 4 into 1 into x square minus derivative of x square plus 3 by 4 into d square of x square, which is equals to e power 3x by 4 into x square minus derivative of x square is 2x plus 3 by 4 into d square of x square is 2. 2 ones are 2 twos are. Is equals to e power 3x by 4 into. Now we can take the LCM of all these three terms. X square into 2, 2x square minus 2x into 2, 4x plus 3, which is equals to e power 3x by 4 into. Now we can split this fraction as some 1 by 2 into numerator 2x square minus 4x plus 3, which is equals to e power 3x by 4 twos are 8 into 2x square minus 4x plus 3, which is our yp. Yp equals to e power 3x by 4 twos are 8 into 2x square minus 4x plus 3. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we are having c1 plus c2x into e power x plus yp, e power 3x by 8 into 2x square minus 4x plus 3. This completes the problem. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.